So hi everyone, really nice to meet you. Actually, last time I was in Belgium, it was sunny and nice, and I came back and I thought to myself, wow, what a nice weather in this country. And today, like the controller on the train said, when we passed the border, he said, welcome to tropical sunny Belgium. And then we got here, and okay, so now I understand it can also rain. But that's okay because I have way too much sun in California, so it's nice to get some rain for a change. So if you don't know what continuous feedback is and you have never heard the term, that's fine. I promise you, I didn't make it up. It's there. I'll show you during the session that it always existed. But I kind of discovered it in my experience, and I'll kind of explain what I mean by that and why I think it's super important to know. Just a few words about me. I've been a Java developer for a while. I started developing some 25 years ago. Probably people in the room that have a little bit more experience than that, but I always feel like an old geezer when I say that because it sounds like a lot. And when I got started, it was with Java, J2EE, Enterprise Java Beans, the whole fun. I survived it somehow. A lot of XML programming for those of you who remember it. And over the years, I transitioned through a lot of different languages. I did some .NET, Python, Ruby on Rails, and lately came back to Java to find out that it's extremely different and much more fun. So it was kind of worth the wait. And throughout that time, I've been noticing that coding practices were really changing. So if you're an old geezer like me, then you know exactly what I'm talking about. If not, then you still may have noticed some changes here and there. Because this is how I used to release software, right? We used to take a CD-ROM, we burned the latest release, and then we gave it to the guys in the QA across the hall, and they would test it. And sometimes we would hear back when there was a bug, usually, and then we would fix it. But otherwise, this was the sum of our involvement, taking something, wrapping it up really nicely, and handing it to the next guy in the chain. But yesterday, with an emphasis on yesterday, this is how we write code, right? So today, and it was great to see it happening, people write tests, thank God. They're running automatically. Also, thank God, and the CI build. We have developers that are responsible for not just writing the code, but for unit testing it and writing integration tests, and sometimes even the deployment tools, Helm files, Terraforms. They're all things that we kind of dabble in because we need to understand and deploy end to end. But there's a question here, and I'll leave it open because I'll get back to it later. What happens then? So what happens the minute after you deploy to production? What is usually your next step? Like you've pushed, you've merged your PR, things start happening, it's going to be there in a while. What's your next step?
Champagne.
And
Start work.
99% of the time, the answer is I go to the backlog, I see what's next, and I take that item because I'm done. And what is your code doing? Who knows, right? But I'm done. And that's what we're going to kind of get back to. Because today, we have the opportunity to use different tools that we didn't have the kind of ability to use back then, even yesterday. Some of these tools help us write code faster. So if you've used Copilot, then you know that A, it's awesome, B, it's crap, and you need to rewrite everything that it gives you, but it still accelerates how you run code, how you write code. But at the same time, code is also generating a lot more data. It's output and input, right? So you're generating code much faster, but then you can get a lot of information about that code. The problem is that you need proper tools in order to make that into something useful. And in both cases, AI is making a big difference. So the question that you should ask yourself is what do you really know about your code? And what tools do you have to know more about your code? And you'll probably say, I know about my code that it passes my integration tests, right? So that's a lot of validations. Integration tests are super important, please write them, but they're also very biased and often very narrow in scope. Unit tests, even more so. So sometimes we get that false sense of confidence by seeing lots of green tests, but nothing works, right? But the tests are green. You can debug your code, right? If you've debugged your code, then you know that this is a great way to troubleshoot an issue. But only if you know there is an issue, and you know where that issue is, and you know where to place that breakpoint, and you're lucky enough to have that issue manifest in the specific request you're debugging out of all the millions of requests that are out there. And some issues are not even specific to one request. They are kind of trending across multiple requests. So the question is really, what do you know about your code? And I'll give you an example. So in the spectrum of knowing very little about your code and knowing a lot about your code, I had a developer in my team who worked on rewriting that data access layer, the DAO. It was a very important change. He worked on it for a lot of time. He wrote meticulous code. It passed all of the tests. He pushed it. And about 3 weeks later, we found out that that code never ran because somebody made a mistake in an if statement. So in this spectrum of what do I know about my code, this developer didn't even know that his code was running, that anybody was using it. I'm not even going to tell you, I know that it makes life better for everyone. I know that it's good. I know that it introduced regressions. There are a lot of other things to know. I'm just saying, Boolean, did it even run, right? No idea. So I went up to that developer and I told him, look, what gives? You worked on this so hard. How come you didn't check that it's running? So he looked at me and he asked me very frankly, how? And I had no good response for that, right? and that's where I started to notice that something is a little broken in how we write code. And yeah, and the problem is that if you don't know your code and if you don't know things about your code, then you end up troubleshooting it. You end up in the long wee hours of the night trying to understand what went wrong. And for me, this was the most frustrating part of that fad that everybody was a part of called continuous deployment. So if you've done continuous deployment, you know that there's a lot of pressure to release often, release fast, release all the time. But essentially, if you're not also getting information back, all you're doing is really throwing features over the fence at a higher rate or a higher velocity. And then eventually what will happen is you'll start seeing bugs. And they would pop up, and suddenly you're in fire brigade mode, trying to run around fixing bug, context switching from what you're supposed to do because what you delivered was never good, because you were focusing on continuous deployment rather than continuous release. So deploying is cool, is easy, right? Everybody can do deploy. Everybody can push a release into production. That's easy. But releasing, that's something else. Releasing also has this concept that it also needs to work, and it needs to be a good release, and it needs to deliver business value, and it needs not to create issues for everyone. So eventually we came up with a name to what we were doing. We called it BDD, and I'm not referring to behavior-driven design that you may be familiar with. I'm talking about bug-driven development. Because essentially this is what we were doing. We were waiting for the next bug. Then the bug came, and we fixed the bug, and we developed the next section, and then this is what we did. But it's not a very efficient way to code. So I'm going to tell you a story about somebody who did something a bit different. And that someone really inspired me to think about this problem a little differently. And I had, at that time, about 10 developers in my team. And one of them, this is the 10x engineer, did something a bit different. He did something terrible, but he did something different. And the story goes like this. I was looking at the output of the application, and I was noticing it was completely spammed with numbers. 60, 40, 60, 70, 60, 30. Like the metrics, right? There are a lot of numbers on my view screen. And I was trying to understand why the hell am I seeing all of these numbers in the output. So I went to that developer and I told him, hey, why did you push this check-in, this commit that actually creates all of this spam to the logs, to the output? And he said, well, first of all, I'm very sorry that I pushed this in. It was supposed to run only locally on my machine. Second, here is what I was doing. I was working on a background process, like a batch job. And as I was working, I wanted to make sure that I was adding more functionality, but the overall performance was not degraded. So each iteration, I printed out how long that iteration took. And I trained my mind in my peripheral vision to have this spider sense where if I saw too many 70s and 80s and not enough 50s and 60s, I knew that I made a bad change. So first of all, don't do that. But second, this guy, out of 10 developers, was the only one who even thought to care about this aspect of the code that he was writing. And at that moment, I realized if I give this guy the right tools, then he's going to be a 10x developer because he's going to worry about the release. Because he has that sense of responsibility that he knows that he owns the code. He doesn't just write it. So to go back to the previous question that we were talking about, what happens next? The question is, what should you do the minute after you deploy your code into production? So you've gone through all of this. Let's go back to the story of Bill, who was the person who wrote the CRUD, the data access layer, sorry. And he did everything right, and he pushed into production. What do we expect him to do next, really, if it's not to take on the next item in the backlog? Any ideas?
Get feedback.
How? And how do you usually get feedback?
There are no bugs. That is the problem.
Yeah, you could see that it's not crashing, for sure. But in this case, it's not like, if you add like an end-to-end feature to the UI, maybe you can check that the new UI is working. But if you are working on the back end, it's a little bit more, it's a little more complex to validate your changes. And at one point, I was also a product manager. Don't ask, it's a long story. But basically, I cared a lot about who was using the code, why they were using the code, and so on. And as a product manager, I was A, not so good at it, and B, I was still dabbling in the code, so eventually they kicked me back into engineering because engineering got tired of me pushing changes in the middle of the night, and then they were discovering it was there only when the release came. But as a product manager, I was a part of the problem. And I learned two things as a product manager that I kind of took back to my work as an engineer. A, I was only concerned with the next feature. Like a developer would come to me and would say, hey, I finished rolling out the user management. And I wouldn't tell him, did you get feedback on that? Do you know that it works? Because I have allocated here in my roadmap time for feedback. No, that never happened, right? I always worried about what's the next feature that's going to come. And B, I had feedback. That developer that didn't know whether it worked or not, he was looking at things technically. From a usability perspective, I had Google Analytics. I had 1,000 different analytics products that gave me a lot of information about what the users were doing. So the problem we're talking about is confined to engineering. The whole organization doesn't care about, and engineers suffer for it. So I kind of went back to the basics, right? So this diagram is like the first one that you'll find if you search up continuous feedback on Google Images. This is like the first one that you'll find. And I told you that I didn't invent continuous feedback because you can see it right here on the diagram, right? It's right there in the middle. But can you spot something that's a little odd about this diagram? I promise to you, it's staring right at you. So you may notice that this is a very fancy diagram, and there are a lot of tools associated with each phase of the DevOps cycle. So we have tons of build tools, tons of continuous integration tools, tons of deployment tools, as it should be. If you check continuous feedback, you will see two things. First of all, a very suspicious lack of any tooling whatsoever. And B, somebody decided that Salesforce was a good continuous feedback tool. And I actually sent a question to the guy who wrote this diagram. I never got an answer about what was the thinking there. Maybe it's some plugin that I'm not aware of that Salesforce has. But the important thing is that it was supposed to be there all along, because it makes sense. You deploy, you monitor, then you take the learning back into planning, right? You take it back. But it doesn't happen. And the whole was kind of staring at me right when I was looking at the DevOps loop. And this is exactly the moment that I learned a little bit about OpenTelemetry. And OpenTelemetry is really one part of the key to making continuous feedback work. So how many people here know about OpenTelemetry or have heard about it? Nice. How many are using it? Very nice. So OpenTelemetry, do you maybe want to say in a few words what it is?
Oh, it enhances observability within your landscape?
Yeah, so OpenTelemetry is absolutely not very important, but it's extremely important at the same time. It's not very important because it's not radical, it's not a change, it's not an innovation. It's an iteration on existing standards, Open Census and Open Trace, and it defines a spec for observability. How should you collect logs? How should you collect traces? How should you collect metrics? But it's extremely important because it's the first time in the history of coding that everybody agreed on a spec, and this never happens. Also, by sheer chance, they also made it open and free. So we have an open standard for observability that everybody can extend, everybody can use, everybody can apply. And if you're the next guy who's writing a library, and you need to pick which observability spec am I going to support, that's not an issue. You're going to support OpenTelemetry today. And what we get from that as a result is that 80 to 90% of the libraries that you're using today already have exporters that are active by default for OpenTelemetry. And this is a big deal because that means that if you want, oh yeah, I don't know, maybe I'll have some time for it later. It sounds like a big project change. We need to plan it out, have a backlog item, add observability to the project, then put it in the technical backlog, then have it be forgotten for ages. Then a new developer comes in, he says, I'm going to do that. Then it's very complicated, and then it's not happening again. Like it happens with every other piece of technical debt, right? That's not the case. It's already supported. It's flipping a switch. It's turning the lights on. I'll show you in a sec. It's very simple. If you don't do it today, you're missing out because the data is there and you can get it right now. So it doesn't matter if you're using Spring or Quarkus or Dropwiz or Micronaut, or if you have Postgres databases or Mongo databases, or if you're using Kafka or using Rabbit, or if you're using Spring Batch, it doesn't matter. All of these things, they already implemented exporters for OpenTelemetry, and they're already active if you enable them. So information becomes a non-issue. How many of you are familiar with tracing? Okay, quite a lot. So let's talk about tracing for a second, because I'm going to show a little example with tracing. So for those of you who are not familiar with a trace is essentially an anatomy of a request. It's what happens when the request is being handled. And the good thing is that it's it's distributed, meaning that if you have multiple microservices, it has this context propagation and can know to kind of show you the entire chain of event across microservices, which is cool and awesome. And B, that we get all of this data from these existing tools that already support it. So here, for example, is kind of a modified version of the pet clinic project that I'm using. And I enabled tracing. So all of these libraries are already contributing information to me. So I'm using Java Spring, which has hotel instrumentation. HTTP, I'm using OkHTTP 3, which also has instrumentation. And Hibernate and JDBC in general also has that information. So when I look at the trace, I can see everything that happens. And the components of the trace are called spans, just in terms of just for terminology's sake. So we have get HTTP, then we might have some domain logic, which we can also wrap in spans, so we know things about it. We have some database spans, and basically we can look at what the entire request looks like. Why is that useful? We'll see in a sec. And this is what a trace looks like in my Jaeger, which is one of the free and open source tools that I can use. Everything I'm going to talk about today is free. So this is a free tool. You can use it to visualize your traces. I'll show you in a sec how to do it. But basically, we can see everything from the SQL statements. And if you drill down, you can actually see the SQL itself that's being executed. Of course, the variables are marked out, so you don't have any sensitive data here. And you can see kind of the flow of control about everything that happened during the request. Is it useful? We'll see in a sec. And then turning it on, that's extremely simple. The first thing to know is that for dev and test, if you want to enable it, we'll talk about production in a sec, no code changes. So you don't need to add anything to your project, any dependencies. You don't need to modify your code, add some references. You just have to add the OpenTelemetry agent, set it as a Java tools option, environment variable. You can also use other techniques like VM options, parameters, and things like that. That's my favorite one. You just tell it what your service is called, because each microservice needs to have a name in the observability space, so it's kind of namespaced by it. And that's it. And you run your application in whichever way you run it. You can set this up in your run config, in your IDE, or you can run it from the command line this way. And it will work. This is the flipping on of the light switch that I mentioned. You can try it at home. You can try it on your own code. It will just throw information. What you do with that information, that's another story. But it will start exporting out all of that data. So let's take a look at some code. Too many slides. So what I'm going to show you now is what that looks like. Now, what this session isn't, by the way, is OpenTelemetry 101. So I'm not going to go too deep on how to enable OpenTelemetry for two reasons. One, there are lots of resources on it, and it's very, very, very simple. And two, the whole reason I'm giving this talk is because I saw a lot of talks that are OpenTelemetry 101, and none of them told you actually how to use it. They just said, here's how you enable OpenTelemetry, now go have fun. But that's not practical, because what we're looking for is not to have observability, but to use observability in order to improve our code. To give you an example of that, I was a few months ago at a company in Israel, and I was talking to the VP of engineering there, and he was taking me to see their fancy dashboards, and they had this hallway, and it was lined with big LCD screens that were showing every bit of impressive graph you can imagine. And I was like, whoa, you guys are way ahead. I have nothing to teach you. Wow, I need to learn from you. And then he said, I'm sorry to break it to you, but I just had a talk with one of my employees, and he confessed to me that he thought the dashboards were a screenshot. He did not understand that they were dashboards or what they were for. And this story, guys, repeats itself. I've seen organizations that use Datadog, that use New Relic, that have every bit of observability with zero actual usage of it to improve their work or to check it. And there are reasons that this is not happening. And I'll talk about these reasons in a sec. But first, let's take a look at what it looks like to have that data. So what did I do? I was on the way to give a talk on DevOps, and I decided that I want to show the pet clinic, but I hate the pet clinic. Why do I hate the pet clinic? Because it's a CRUD app, basically. It does nothing. It's a simple app that doesn't exist in the real world. Real-world applications are not pet clinic. So I decided to add some complexity to it. Because I was a bit bored and I couldn't sleep on the flight, I said, let's create a mock service for vaccinations. And then let's add some logic to work with that service to get vaccinations and to check vaccinations and add that information in. So how does it work? Let me run my app. And I have turned this light switch on. I'll show you in a sec. So I'm running my app, and now I can go browse to it. And voila, here it is. And I can go see an owner. And if I do, then you'll see that there's a new needs vaccine. I know the UI is very fancy. And then I can also add a new pet. Perfect. And I can assure you that as I add this pet, there is a microservice, there is an asynchronous call being made that is checking this person's vaccination status, and it will later update it if it does need vaccination. So all in all, very simple code. Now, being a very disciplined developer, I also added tests. And because I love test containers, I use them to write some integration tests. So I have some tests. They all pass. I can show you where they are. But basically, you need to believe me that they are there, and they're testing all sorts of different scenarios, and they all work. So we're going back to the original question of what do you know about your code? What do I know about my code? A, my tests are running. B, I'm the best developer ever, so it must be great, and it couldn't be that I made any issues or bugs. And C, that when I debugged the code, I kind of saw it working. So now let's see what I can know about my code. So as I was working, I was actually enabling OpenTelemetry behind the scenes. I also ran an open source application called Jaeger. And by the way, I will send you all of the steps to enable, run Jaeger, and other things are in a website called continuousfeedback.org that I created. That is essentially just a page with a lot of links. And it covers everything such as setting up OTel, collecting data, automatic instrumentation, a lot of things. So you can, if you are interested in the OTel 101 bit, go check that. I don't want to waste any time on that now because I want to get to the important parts. So I said we can get some traces out of the code. So let's see what kind of traces we got. I have my Jaeger instance here. This is their logo. I think our logo is nicer. And here we can see some spans. Awesome. So we can see the get operation. We can see the post operation to create the new owner. All in all, pretty good. Let's take a look at the get operation and see if we notice anything in the trace. How many developers here use Hibernate? OK. So if that is true, how many people here can tell me the issue that is staring us right in the face here? Just by looking at this. Yes, yes, for sure. How do you know that? Because you've seen that before. But it's very obvious and evident when you look at the trace, right? Did I know this before when I was writing my code? No. Did my test pick up on it? No. But right now, I'm seeing things about my code for the first time. Let's continue. So, how many of you know about an anti-pattern called an open session query in Vue? Yes, so for those of you not familiar with it, it's when you access a lazy property in Hibernate while you're rendering the view, and it's triggering a SQL call in the rendering phase, which is a no-no. So here you can see the rendering trace that was provided to me automatically because I'm using Spring. Again, no need to change my code. And you can see the queries. And if I want to see what is in the query, I can also double-click on that and see exactly what is the query that is being fetched. And of course, it's my bad. Vaccinations is a table that I added, and I forgot to fetch that data ahead of time. So it is 100% related to my change. So all in all, we saw that we can get really good data about my application. But now I'm going to tell you something sad, because I enabled all of this in my organization, and I told developers, this is what you need to do. Now you use this every time you kind of check in or develop your feature, look at the traces, and your work will be improved. Now, how many developers do you think actually use that? 2 developers, 1 time. That's it. That's what I got. They were proud of themselves. They showed me what they did. One of them found something. The other one didn't find anything. The one who found something didn't want to check again because it took them a lot of time to fix it, and they didn't want to get in trouble again to discovering issues that they didn't want to fix. The other developer didn't find anything, so he said, well, I didn't find anything now, so who's to say I'm going to find it next time? What is the problem? Why is that happening? And the answer is also in the name that we have for this phase of the DevOps cycle. It's continuous feedback. It's not manual feedback that I need to remember to go and check every time. We had the exact same thing with tests. I was trying to get people to write tests. There were no continuous integration builds once upon a time. They were too slow. And we used to run our tests manually before our release. And nobody wanted to be the one to have to run the test and see that they have been read for months because nobody noticed, and then he needs to be the one to fix them. So nobody did that. So if feedback is not continuous, if it's not a byproduct of you working on your code, then you may as well not have feedback at all because nobody's going to check it. But there is another problem in what we're seeing here. You guys know about N+1, so it completely jumped out into you. And that's a very classical, simple problem to see. I can promise you that more complex problems are much, much harder to spot. Concurrency issues. Is anybody going to keep track of how concurrency works? Calculate the correlation between concurrency and duration, remove outliers, run regressions to understand if we have a meaningful change or not since the last commit, and then telling me this code doesn't scale? Probably not, right? Why? Because we're developers, and some of us don't remember statistics, and the ones they do want to forget about statistics. At least me, sorry. I know some other people love it. And as a result, there is an expertise gap, not to mention a huge cognitive effort that I need to spend, often to get no results at all, because who's to say there is an issue? And that's kind of where my story fits into it, because I was looking at this and I told myself, something is wrong. There is a slot called continuous feedback. People are not doing it. Now we have the data with OpenTelemetry. Here it is. Potentially, it's in your laptops right now, the moment you activate it. But even if it's there, it's not going to do you any good. It hasn't done us any good. So I thought to myself, can we create something that will actually do this for me? So you guys just looked at this and you said, hey, that's an n+1. I don't need you guys to do it. We can teach an algorithm to do it. We can teach an algorithm to look at the concurrency levels and detect if we have a scaling issue. We can teach the algorithm to spot other anti-patterns, maybe security related, maybe others that are just bad practices. We can teach it to spot changes based on the code that we're making. And we can get that data across to the developer automatically so they don't need to reactively look for it. They can get it proactively. And of course, it needs to be free, right? Because otherwise, if it's not free for developers, they're not going to use it. So this is what we've been working on. And I want to show you a little bit of what I've been doing, not to sell you on that. Please, if there are other solutions, and if you have a proprietary solution you're paying for, and they have this capability, just use that. That's great. I couldn't find anything else that's free right now in the market. Otherwise, I would show it as well. But the point is that it does try to implement everything I just said. And it's just the beginning. So there's a lot more to do there. And part of the reason that I'm showing you this and that I want you to try it out is to give feedback. Because what we're doing right now, and we have by now hundreds of users with almost 100 new installs each week, which is great, is that we're using that community to build the knowledge base. So right now, there are like lots of things that we know to find out, but I'm sure there's a lot more that if we picked the brains of senior and experienced developers enough, we'll be able to build into the product as well. Before I show what that looks like, any questions? Perfect. So let's look at a different type of experience. I'm looking at this same code over here, but the first thing is, I'll make this a little bigger, is that you may notice that there is a little observability toggle here with a green light on, meaning that it actually detected new data recently. And if I look at it, I can actually see, sorry if this is a bit small, I can see the APIs that I just triggered right here in the ID. And I can also see that there are some information about them. And let's see what I can find out. I would just say that in order to enable OpenTelemetry, and this was the first thing that we wanted to make very easy, all I needed to do was to change a toggle. So even that small thing of downloading an agent, configuring the service name, adding environment variables, we've automated all of that. So basically what I need to do is install this plugin, which is just in the marketplace, and enable observability. These are the two steps that are required of every developer that wants to test it out. And now I can go and look at what Digma can tell me about my code. Let's look at that first code. Well, wow. The first thing you'll see, make this a little bigger, is that there is an n+1 suspected and there is an open session in view. These two things that I missed are just there. And I can see more information. So I can see that this suspected n+1, for example, there are two sources for it. One is defined by ID in the owner repository, and the other is the rendering, which we just saw. And if I want to see more, if I want to see, OK, what does that n+1 look like, I can click the trace button, and I can see the trace exhibiting that problem. Now, I want to just stress how meaningful this is. Because what we've done is essentially flip the pyramid on its head. Instead of having developers sift through logs, find issues, we're starting from the issue and then allowing you to go to the traces and logs and to see what does that issue looks like. So we've made something that takes a lot of cognitive effort to find out if there is an even issue, much simpler. And now I can kind of drill in and see. And yeah, it says that the problem is defined by ID, and I can go to the code from here. So it's kind of a two-way mapping between the trace and the code. I can navigate the trace and go to the place in the code where this is happening. And for each one of them, I can actually see, first of all, who's using this code. So I can see these are the APIs that are using this. OK, probably it's a repo call, so that makes sense. And I can see the select statement, but I can also see the impact. So sometimes an n+1 is not that much of a big deal. Sometimes an n+1 is tolerable. In this case, it's repeating it 11 times, and it's costing me a millisecond in dev. Is that a problem? I don't know, but we'll need to test it out in maybe more complex scenarios. Now, I've also run my integration tests with this, and I have some concurrency scenarios in my testing, and they're telling me other things about my code. So if I look at this other piece of code, I start to see insights that have to do more with how this code performs. So this particular piece of code that I wrote that creates the owner is scaling badly. What does that mean? It means that the more I scale it, the performance goes up, but not linearly. It goes up, or maybe very steep. And I can see that after about 19 executions per second, the performance starts being really bad. And I can identify where is that area in the code where it's doing the bad scaling. And remember, I told you before about finding the correlation between concurrency and duration. This is what is happening here. So we can see when we run it 30 times concurrently, or when we run it 5 times concurrently, there is a big difference in the performance. And after removing all of these outliers and analyzing that, we were able to find 2 things. First of all, that there is a problem. B, where that problem exists. So if I look here, I can actually see the root cause. And the root cause is the owner validation, validate owner, whereas external service, which does sound like something that would cause a scaling issue. And I can go there and see where it is in the code and find out why it's such a bottleneck that's slowing down my code. So what we're trying to create is a different kind of development experience, one where you have this intelligent agent that is always looking at your code, always studying the runtime information, always looking at the observability data that today is really easy to get, starting from dev, but then very easy to get information from CI into it, and then production is another thing. I'll talk a little bit about that in a sec, but it's also possible to get information from there. And then translate that not to raw data that would be meaningless, but to data that could be meaningful for me, that could show me specific things about my code. And I think this is kind of the tragedy of monitoring and APM tools today, because they all seem to target DevOps teams, SREs, IT. The language of the tool that we're building, like if you look at our database and you check what are the objects there, you'll see functions, events, flows, which is basically how functions are being used together and what are their characteristics, classes. These are the objects that we deal with because our objective is to provide feedback back to the developer and not back to different teams that work with things that are not code. Now, let's talk about production a little bit. And by the way, I'm not going through everything in here. There are lots of things that you can discern. Some of them have to do with usage and usability, especially in large, complex systems where it's not that easy to understand who's using this code in what flows and in what way. And especially for legacy code. Legacy code works great with OpenTelemetry because a lot of these libraries are supported. Some of it is about performance, some of it is about errors and exceptions. So this OpenTelemetry also gets all of the exceptions and call stacks, and I can navigate the call stack and see where it's happening in the code. Oh, incidentally, let's take a look at that other operation that I implemented before I move on further. Remember I told you that I was actually, one of the things that I was doing is I was pinging an external API service, and it seemed to work really fast, right? But if I actually look at the trace, you can see that it's making a lot of GET calls. And if you check, it's actually running for a lot of time. Again, something that I would kind of whisk by me if I did not pay attention or if there wasn't a tool to alert me that something is wrong. And in here, I had a simple problem where I had a leaky abstraction. I was using a collection object that was behind the scenes, just making too many calls to the API service. So it's kind of a chatty API kind of a thing that might require caching, for example, to fix. Now, let's talk about production for a second. So I really recommend using this in dev and CI, but what about production? Because like the most asked question that I get is, if I enable this in production, what would be the cost of the tracing and so on? So there are two answers to it. The first answer is that the cost really depends on how you use it. So I could say the same about logs. Writing a log statement is costly. If you have a loop that is running 100K iterations, and for each iteration you write a log statement, it's going to slow the loop down. However, if you have a Spring application, then you have so many middlewares and so many layers in between you and the user that add their own overhead, that if you add a trace to the to each high-level operation, you're not going to feel a thing. But for production, I would not recommend using this technique, which is the agent, because it uses a little bit too much reflection to my taste. Thankfully, the Spring team, and specifically the micrometer tracing team, has added really high-performant tracing into Spring. The benefit of using that is that it's very performant. Its effect on your production performance will be negligible. You will not feel it. The only thing is that it does require adding some dependencies, adding some configuration, so some system properties to configure it. I would still recommend using it, but only after you're convinced that it's giving you value. Then you can maybe go and add it to your production. Just add, it's no big deal, just adding a couple of dependencies, and it works with the Spring Actuator and with some other libraries, and it works great. The other thing is that it's not as automatic. What you saw here was I enabled OpenTelemetry, and suddenly all of these libraries were giving me information. That doesn't happen as much with Micrometer. It's still giving you JDBC, and it's still giving you some common libraries like Kafka or Rabbit, but some other smaller libraries won't just start spewing out traces. You'll need to configure that yourself. So a little more tweaking, but much more performant, and that's what I recommend for production. Cool. Sorry, any questions about this? Okay, you guys that are using OpenTelemetry, how are you using it right now? I think you mentioned you were using it, right?
Yeah. Well, we don't use tracing at the moment.
Just metrics?
But we use OpenTelemetry.
Okay.
And we are at the beginning of integrating the technology, but I've used it in the past with Prometheus Polar. Visualization through Grafana.
Yeah, I didn't show Prometheus and Grafana, even though I have this demo on my laptop. They're great. One of my beefs with Prometheus and Grafana, like I love the fact that in Grafana open source, you can just load any dashboard that somebody already created, and there is one for Spring 3, and it already contains a bunch of statistics. If you look at the statistics provided there, none of them will help you to develop your code. It's like, yeah, what's the RAM consumption on my JVM? And come on, like it's not telling you something that's going to be useful as you write code. It's telling a lot of things that will help SREs and DevOps guys. So, and that's usually why I don't show it as much, although I did manage to create a small amount of dashboards that I think could be helpful for a developer, but maybe I'll publish them as well. I do have an example. In the continuousfeedback.org website that I created that has a lot of links, one of these links is called Effective Observability with Java Code or something like that, and in it there is an example of how to create a dashboard in Grafana that is really helpful. Yes?
So if I understood well, you just installed the plugin,
Mm-hmm.
IntelliJ,
Mm-hmm.
and that was it. So no need to install
Yes, Jaeger is included. One,
In the plugin.
yes, one thing that we are doing that is interesting. If you work with OpenTelemetry, it's like I short sold some of its capability. It has a lot of depth. Okay, one of the things that it does well is the whole how do you collect the data thing. So sampling, head first sampling, tail based. There's a lot of strategies of how you. Let's say you have your, I don't know, Booking.com or eBay or I don't know a large website, then you're not going to take all of the transactions and look at them because that's too much data. So there's statistical sampling that you do. And one of the issues that you have with sampling is what happens if you sample out the wrong stuff. So like yes, you've sampled out, so now you're capturing only 10% of your requests, but 90% is a lot of data to lose. So one of the things that we're doing, which is more interesting, is we're sampling based on importance or how interesting the data is rather than sampling statistically. So what we're doing is we're pre-processing everything. We're looking at the span and we're saying, is this like a million other spans that we already have a record of before? Or is this something unique and interesting? And there are many criteria to determine that. And then based on that, we save an example set of interesting things. So for example, I already have an example of how this flow performs in the median percentile. So I already know that. And I can capture a more recent example, but I don't need to save a million traces that look exactly the same. Now, it takes a lot of intelligence to know which ones to keep and which ones to lose. But it's still not based on statistics. It's based on whether it's significant. Maybe this exhibits an error that I've never seen before. So I should keep it and have it as an example of that specific error. So this is what we're doing there. But in general, all you need to do is install the plugin. Behind the scenes, it does require you have Docker on your machine because it will start Jaeger, for example, as a container.
This data is taken by running the application locally.
Yes, all of the processing is local, which is another thing that we've done to make sure that people don't have a problem because everybody wanted us to make a SaaS service at first. So we said, hey, let's make a SaaS service. Then everybody said, whoa, we're not giving you our data because that's private information. So we decided to, OK, let's just make it into something local you can run, and no data will get out. So that's kind of a better, that works better.
And then in dev and in test, I imagine it would be not this plugin, but something.
So in dev, it's just a plugin. In test, if you're running local tests, also, you can use this plugin. If you want to run it in your CI, probably not a good idea to send information from your build server or from GitHub into your machine. So you probably want to run it somewhere, which is why conveniently we provide a Helm file or a Docker Compose file, and you can just run it anywhere that makes sense, and just configure your collector to send the data there. So all in all, pretty simple. Cool. Who else said he was using OpenTelemetry? OK. And before, I know today you're using Digma a little bit, but before then, did you use other tools?
So we use a combination of tools. So we have introduced Digma for the local development. We use for the metrics, we use Prometheus and Grafana. And for the integration environment, there we use Elastic APM for the distributed tracing.
Nice.
And in correlation with logs. And what's interesting, and in our use case at least, is that we have a mixed park of JBoss applications and Spring applications. And for the JBoss applications, we basically use the Java agent from the start to collect those data. And for Spring, we were going to use Micrometer because we were already using it for the metrics.
Yeah.
What we found out is that currently Micrometer is not at the capacity that Spring Sluice, for example, previously was in terms of observability. There are still different libraries, even within the Spring ecosystem, which are not covered.
Yes.
And so we currently fold back to the agent.
That's a great point. And I think I mentioned it. The benefit of that library of micrometer tracing is the performance, but it doesn't do as much magic as the Spring agent does. The Spring agent really does a lot of magic, so that all of the libraries that you're using are going to export a lot of data, and many of these libraries, like the best way to see for yourself is just go to Java auto instrumentation for auto, and you'll see there's a page here that just lists out the libraries that are supported. And all of these libraries are the ones that will start kind of sending out traces the minute you enable it. And you'll see a lot of different things there. Some of them legacy, some of them new. And that's really great. Like that's the bonus of the agent, where it just activates everything. But then as you imagine, if you activate everything, there's going to be a performance hit. So measure, like I wouldn't just run it in production before I test it in staging and see that it doesn't degrade the performance. And you can, of course, enable or disable each such library. So for example, if you see, I don't know, JDBC is giving you an issue in production, you can make sure that it doesn't send data. Yeah?
When you say that the agent will just start collecting everything and so on, does it assume that your code is written in an idiomatic way or something like that? Give an example, if you program in Spring and you would like
If you
to
what?
test a template,
Yeah?
you just create it with new,
Mm-hmm.
I can obtain it from the framework. If I obtain it from the framework, then Spring will add all the telemetry and so on.
Yeah.
If I just create it with new, it will not do anything.
No, it depends
In
on
the case of the
it depends
agent,
on which action you use. Okay, so some actions have that built in, some don't. If you just and that's a great point. If you want to look at code, specific code, that's not a part of the automatically instrumented world. That's not all of these libraries already supported. But let's say I have my domain logic, and I want to add code to add observability to my domain logic. So in OpenTelemetry, there's a really nice way to do it, which is to add the with span annotation. And what that does is essentially encapsulate that in an OpenTelemetry span and already provides a name for it based on the name of the function and so on. So all I need to do is to add this annotation, and now this code is something I will track. And libraries like, and tools like Digma or like Jaeger or like others can now take that information and make it into something useful, hopefully. For Micrometer, there is a different abstraction, which is, I think, what I don't like about Micrometer being different. They have the observable API, and they have the observe annotation. It's a bit more sophisticated. Like what they did, which I like, is they merged together metrics and traces, and logs. So no, this also captures logs. Like, logs that you capture here will automatically be associated with the trace using the trace ID, and you'll be able to see it.
It will be in the MDC as well?
Sorry?
It will be in the map diagnostic context of the log itself?
Yeah, it will add the trace ID, and if you have the right tool, like in Jaeger, you'll be able to see the logs for each span, for example. And what they've done is also, if you add the observe annotation, they will also take a stopwatch kind of and save some metrics about that specific area. And you can also track variables, which is really cool. So you need to tell them if it's you guys know what cardinality is? Basically means, does it vary a lot, or is it like a small set of values, so that you know if you can create like a nice histogram out of it, or if it's too much and you just track the value. So you can tell it, hey, I want to track this variable, for example. And then you can look at the observability, let's say based on the, I don't know, lengths of the array that was received into this function, and kind of see, okay, maybe there's a correlation between the number in the array, and after a while it's not usable, and so on. So they're doing their own interesting things. I do hope they will support with span as well. I I actually talk to them quite a lot because we're doing a lot of integration within Digma. Within Digma supports both. So essentially, if you go in Digma to your settings of the plugin, you have kind of this Spring Boot observability mode, and it can be either OTel agent or micrometer. So you can kind of select which one works for you. But yeah, it's a difficult choice. I would start, if you are not doing any OTel, I would start in dev and test using the agent because you'll get the most value and you won't feel a thing in terms of performance in dev and test, and it will be automatic and magical, and you'll be able to get a lot of important insights. Later, I would consider if you're using Quarkus, you can't use any of these. And this will happen automatically. If you use Digma, you need to use the Quarkus extension, which is, like Quarkus doesn't play nice with the agent, but Spring and other frameworks do. Cool. Any other questions? Cool. So we talked about this. OK, so we talked a little bit about what's the issue with the continuous feedback, and I hope that this solves some of it. And overall, my goal right now, and the fact that I'm going out and speaking to a lot of people, is first of all to get more feedback about Digma. I'm not at all ashamed about the fact that we need more feedback because, one of the reasons we created this as a free for dev tool is because we need devs to tell us what we're doing wrong. Very vocally, as devs can, and that's the only way we can improve. Like when somebody calls me up and he says, yeah, this is really nice, then I say, OK, this is useless. Tell me something negative. And then they can come up with things. It's easy because we're still just beginning, so a lot of things need to be correcting. So we're collecting a lot of information. And the other reason is that I really think and see we're dogfooding Digma ourselves and our team very heavily. And also, by now, I see how developers are using Digma in the field. And you can see how it makes that switch between I'm just deploying the code and I don't care about the information, and I always see that data. And if there are important things, then I'm made aware of them. And the more that becomes a part of the cycle, the more I understand the code. And that, for me, is kind of what I've been trying to achieve from the beginning. That's it. So 2 websites that I want to mention. One is continuousfeedback.org. If you go to continuousfeedback.org, it will contain all of the links that I mentioned. It will also contain my contact details. So if you want to shout at me yourself and tell me how bad the product is, please do. I promise I'll be very glad if you do. I will not be upset at all.
You've been using it. What is your feedback? What is your input? And,
mostly positive, unfortunately.
Go.
The only issue which I already mentioned to you is currently we have this kind of microservice architecture or distributed monolith architecture. Let's be honest, for which we...
I love the term. Can I use it? I'm going to use this in my next talk, yes. The distributed monolith architecture, yes.
Yeah, and which means that every project is usually in its own IntelliJ IDEA workspace. And currently that means that each and every time we want to record and gather insight, we erase the volume where the data is recorded just to not be polluted by the inside of the other project.
Yeah.
That's my current only complaint.
Yeah. So filtering is something that, for example, we just received, which is a great usability feedback. And it's great when we receive things not just from one person. This is a recurring request, I have to say. So one link is continuousfeedback.org, and my details are there. If you if you kind of click on Digma, then you'll be able to join our Slack channel, which from the plugin, like it's right over here. So in the menu, there is like a Slack Digma channel invite. If you click on that, then that's a great place to pour your criticism, good and bad, but hopefully bad. And then if you're interested in becoming a part of our beta, you might think, but it's released, why do you have a beta? Because there are some users that want to be more engaged, and then they can sign up for a beta, and that's just, it requires having a session with me every now and then and spilling you the beans about kind of what you've seen, what you didn't see. It's just for people who are interested in becoming a part of that journey as well. I want to close off with a story about something that we're still developing, but that I'm really excited about. And I want to tell you the inception story of it, because I think it really describes for me some of the reason for why we're doing what we're doing. So I had a meeting a couple of months back with this super developer at eBay. Oh, sorry. At some big retail competitor of Amazon. And no, it's nothing embarrassing. It's okay, I can say it. So I was talking to him, and he's this super developer. Why am I calling him a super developer? Because his job, this guy, they bring him in when they start a new project in eBay. He comes in, he puts everybody on the right track, solves all of the hard problems, and then he moves on to the next project. So he has the best job. Like he never deals with all of the shit. He just starts, he solves the interesting problem and move on. So I talked to him, and after I finished telling him how much I'm envious of him, we started talking about like what are the things that he would like to learn using a tool like Digma. And he said something amazing. He told me, look, we have a lot of batch jobs that are running in eBay. And we choose how many threads do we want to scale that job to. And do you know how many threads we usually scale the jobs to? And yes?
One.
No? So he said, amazingly enough, if you go to 99.9% of the batch jobs running in eBay, you'll see they all run on exactly 100 threads. Now, you might think to yourself, what is this magic number? That somebody did this very, very deep research into trends in concurrency and managed to think that 100 is the magic number that we should all use. So he said, first of all, the one job that doesn't have 100 is one that I created. And the rest of them that all scale to 100 use a constant value called default concurrency level that somebody wrote sometimes 10 years ago, and ever since everybody just defaults to that. And I said, wow, that's interesting. And what would you like to happen? Well, he said, you know, by now, if I look at the observability, I have thousands of examples of how it's behaving in different concurrency levels, because maximum is the 100 is the maximum, but sometimes there are less jobs, sometimes it's more. So I have this kind of variety of different concurrency levels, and you can tell me which is the most optimal in terms of throughput. For example, let's say I have a blocking operation because it's using a table and locking it, then it doesn't matter if I add 100 threads. They're all, like the marginal bonus or the gain that I'm going to get from each thread starts being negative because it's just locked on the same operation. But people go 100 because that makes sense. And sometimes maybe 300 would be better. Maybe you can look at the statistics and see, wow, this is increasing. So if I had another 100 threads, the throughput would really increase, sorry. So he was saying, can you find that out? And from the observability, just tell me what is the number I wish I need to put in if I want to optimize for throughput, if I want to optimize for latency, or if I want to optimize for resource utilization. Maybe I want to, like eBay doesn't have that problem. They like use as many cores as you want. But some other companies want to reduce the resources they're using. So we said, hey, that's a great idea, and we're rolling out this feature next month, hopefully. So that's the kind of thinking that, and why I think this is such an amazing potential for how we write code. Because my sense of it, having worked on this for a while, is that I'm just discovering the kind of questions that we can answer that nobody posited before, because nobody thought that this is kind of information that we could get. That's it. Thank you very much. It was a really pleasure talking to you. And if anybody has any other question, feel free to ask now or after. Yeah.
How do you keep track of versions in production versus the local version? If a method has changed, the code has changed, do you?
Great question. Two ways. The first is we have this logical entity called an environment. So we save the local data in one environment. We can have different environments for staging, for production, and so on. The other thing that we do is we automatically save as a part of the observability. It doesn't come with OpenTelemetry, but we save the commit hash as a part of the observability data. Now, currently we don't do much with it, except notice if something started happening from a particular commit. But theoretically, this could really help us later triangulate issues using commit, which gives us the code, the issue, and basically start building a timeline of code changes versus issues. And we're working on that, but it will take a little bit more time. Cool. Nice. So yeah, please join the Slack channel and let me know your thoughts. And there are some Digmos here. This is, by the way, I was just saying.
A little bit scary though.
It's not scary. It was created by one of my developers, who's also an artist. So when we started the company, he was like the second developer, and he really likes to draw. So I told him, why don't you draw a logo? And he came up with this bat, which I think is really cute. So if you want to take one for the kids or just for stress, I wore out like 10 of these by now. But yeah, you feel free to grab one, and there are some nice stickers as well. Perfect. And tell me where the bar is.
It's too many.
Perfect.
Well, thank you again, Roni. That was
Thank
a
you,
great
guys.
presentation.